Good afternoon to everyone. This is Dr. B. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. I'm very happy to inform you that to understand about today ELRV topic, that is problem solving on hit or miss transformation. Okay, so let us we see the first of all the problem solving on hit or miss transformation. How we can be considered as a problem statement, and how can you are going to solve such a problem. So basically, we are going to be prepared such a problem statement and solution of that same. We are had to understand about the principle about hit and mass transformation is a general binary morphological operation that can be used to look for particular patterns of foreground and background pixels in an image. It is actually the basic operation of binary morphological since almost all the other binary morphological operators can be derived from it. Hit or miss transformation is an operation that detects a given configuration in a binary image using the morphological erosion operator and a pair of disjoint structuring elements. So the result of the hit or miss transformation is the set of operations where the first structure element fits in the foreground of the input image, the second structure element misses it completely. So we had to go through this. The structuring element used in the hit and miss is a slight extension to the type that has been introduced or for the sake of erosion and dilation. In that, it can be contained both foreground and background pixels rather than just foreground pixels, that is, both ones and zeros will be varied. So note that the simpler type of structuring element used with erosion and dilation is often depicted containing both ones and zeros as well. But in that case, the zeros really stand for don't care and are just used to fill out the structuring element to a convenient shaped kernel, usually square. So that usually square, how we can keep don't care in the sense the shown as a blanks in the kernel in order to avoid confusion. That is, these don't cares are shown in as blanks in the kernel in order to avoid the confusion. So an example of the extended kind of structuring element is shown in figure. As usual, we don't want we do not as usual we denote foreground pixels using ones and background pixels using zeros. So foregrounds will become ones and background pixels will become zeros. So such a representation based, we take one of the example one, that is the extended type of structuring element used in hit and miss operations. This particular element can be used to find corner points. So that is, if it is what you mean here, this is nothing but don't care element. Okay, don't care element. That is the meaning what we are understanding about the complete what we called blanks as blanks, which we are understanding. So these blanks are considered as a don't care. Okay. So coming to the figure number 2, where the structure figure number 2 for structuring elements use it for corner finding in binary image using the hit and miss transformation. Note that they are really all the same element but rotated by different upwards. So the hit and miss operation is performed. The hit and miss operation is performed in much the same way as other morphological operators. By translating the original of structuring element to all points in the image and then comparing the structuring element with the underlying number of images. So if the foreground and background pixels in the structuring element exactly match foreground and background pixels in the image, then the pixel underneath the origin of the structuring element is set to be is set to the foreground color. If it does not match, then the pixels is set to the background color. So match means foreground color, background means does not match means background color. For instance, the structuring element shown in figure can be used to find right angle convection corner points in the images. Notice that the pixels in the element form the shape of a bottom left convex corner. We assume that the origin of the elements is at the center of the 3 by 3 elements information. Of course, in order to find all the corners in a binary image, we need to run the hit and miss transformation four times with four different elements representing the four kinds of right angle corners found in a binary images. The figure shows that four different elements used in this operation, which we have to understand how hit and miss operation will be performed. You can see this hit and miss operations are of an image A by B is denoted by A, what we call a hit A mass operation that we are applying here, structuring element operation as foreground and background elements. B is a pair of structuring element, then B equal B1 comma B2 rather than a single element. B1 will become set of elements of B associated with an object and B2 set of elements of B associated with the background. The hit or miss transformation is defined as follows that we expand in association formula of hit and mass transformation in between A and B. So this transformation is useful in locating all pixel configuration that the match the B1 structure, nothing but a hit, but do not match that of B2, that is a miss. So that the hit or miss transformation is used for a shape detection. Let me take this example to understand about usage of the hit or miss transformation to identify the location of the following pixel configuration. In the image below as given two structuring elements B1 and B2. This is B1 and B2. This is sharp. You can understand that 0 represent as a background and 1 is represent foreground. Based on this image, we can apply which one is hit and which one is hit or miss. So I've applied here to find out that A1 with A with B1 and yeah, so we'll get the your solution. Then complement of A will get this and A complement with B2 will get this and A and B hit miss we compare with the original image in between original image of hit miss hit to miss hit miss transformation. So let us take the figure below shows an example of applying the hit or miss transformation on the image in the previous example. So there we find that foreground and background is zero, nothing but black, and foreground is nothing but white color. You see, A part bigger is shows binary image, B part is showing the resultant of applying hit or miss transformation based on matching. So you can see there the which part is matching and which part is not does not matching. So it does not matching pixels are becoming zero because it is background. Which part of image is matching, nothing but the pixels which your transformation between these two are matching, then that part alone will be attained as one. So that is the example which will help us to show for the explanation of the solution. Let you see there for a solution explanation. Therefore, the hit or miss operation comprises three steps. Step number one is erode image A with structuring element B1. Number two, erode the component of image A, that is complement of image A with structuring element B2. And third step, applying the logical operation in between A and B2, in between B1 and B2, then we'll get under results from step 1 and step 2. The structuring elements B1 and B2 can be combined into a single element B. Let us you see based on this explanation one example. Here the structuring elements left to hit, middle to miss, right towards to finalize the combining. You see, what is mean 0 is background. What is the meaning of 1? It is nothing but foreground. In this case, we are looking for a pattern in which the central pixel belongs to the background while the north, south, east and west pixels belong to the foreground. The rest of pixels in the neighborhood can be of any kind. We don't care about that. Now let's apply this to an input image for the sake of mapping. So if you go to map in between the central element of 0 to 1 and 1 to minus 1. What do you mean this? 0 is become background, that is background. 1 will become foreground and minus 1 will become which is not does not match. So we apply that input binary image towards to get output binary image in between the 0 to 255 number of pixels. The number of pixels are helped towards to mapping from input binary image to the output binary. So example 2, let us we suppose we wanted to fit a T-shaped pattern in the image defined by the your part of B1 such that it does not contain the pattern defined by B2, its right neighborhood. 0 represent 0 below represents that we don't care about these positions. So below figure shows how to combine two sections into one. So B1 is combined with the B2. B1 is combined with B2. You see now 0, 0, 0, 0 means don't care. 1, 1 here, 1, 1. 0, 0 here minus 1 will become minus 1. Here 1, 1, 1. Here 1, 1, 1. And 0. What do you mean 0? 0 will represent towards to get your don't care. So that means you see now it become a T shape. It become a T shape. That is what we have to understand. Now just compare the underlying pixels values with the combined S. If it matches exactly, then the pixel underwent the origin of this is set to 1 and else 0. So let's take an example. Suppose we want to find the above combined structuring element. SE means structuring element. In the image shown below, clearly the one on the lower right matches the pattern defined by the combined structuring element is to get results as right side. You see there, heat or mass information compare again the same process. So we are going to be matched together, match, and wherever match, it's only getting output. Doesn't match is become zero. That is background. So this is the output what we want to get. So as we see that terminologies in the morphological image processing, all morphological processing operations are based on mentioned terms. The structuring element, it is a matrix or a small size template that is used to traverse an image. The structuring element is nothing but a C is positioned at all possible locations in the image, and it is compared with the connected pixels. It can be of any shape. Fit is nothing but when all the pixels in the structuring element cover the pixels of the object, then we called it as a fit. Hit when it and at least one of the pixel in the structuring element cover the pixels of the object, then we called as a hit. Miss means whenever the no pixels in the structuring element cover the pixels of the object is called a miss. Now we understand in between hit, miss, and hit based on structuring element. Let us we take the based on that type of hit based on we are understanding the comparison in between hit, fit, and miss. So we have here towards understanding closing and opening concept based hit and how we apply in the sense we have to concentrate about the definition of dilution and erosion. Then it is easy for extending this in terms of erosion, extending in terms of dilation. So with this, I want to close today our discussion on problem solutions based on heat miss problem and heat fit and miss also. So I'm very thankful for your patiently listening on our problems which we discussed based on the concept. Okay, I'm thank you so much, and also I'm extending my thankful to you towards to billable. You can also refer these two textbooks for the sake of some more problems which you can be concentrated towards to get your own knowledge. Thank you so much once again. Thank you. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.